All right, so I am back and having a look at the P2P library for another time. And I think we left off last time having dug pretty deeply into this like server and like how a message is received through the like peer-to-peer network. So it kind of comes in and then it like gets processed and passed off to the like the relevant queues. I think I want to change the other way around now and have a look and see what happens when you want to create a message and send it out. So instead of looking at the listener and seeing what happens when a message comes in through the listener, I want to try find out when we like create a block, how it gets broadcast to the network. And I think I might just open up this dial and see what's in there first, because I mean, dial to me kind of sounds like something going outwards. So node dialer is used to connect nodes in the network. I mean, it kind of sounds like what I'm doing. So dialer creates outbound connections, good. Then submits them into server. Static dials are pre-configured. The dialer attempts to keep these nodes connected at all times. Dynamic are created from node discovery. So I guess this is like hard-coded nodes and also what you pass in via like the command line and stuff if you say you got like trusted peers and stuff. Dial scheduler. That I assume is now going to be the struct that's got everything in it. So here's our new. We create the new form of it, and here are some of the functions. We add a static, we remove a static, we add a peer, we remove a peer. It has a main loop. So I'm not sure if this is going to be something that's like you create one for every peer you want, or if there's just one and it manages a big list. Actually, that might be a good thing to check. It gets added to add peer channel, and it gets add static channel. It's all done via channels, which is interesting. So there's our peers and there's our static. And they're a map from the enode IDs to a dial task and a connection flag. Interesting. If we've got a connection in them, what's a connection flag? Is it just a bool, or is it like damn. And what we want is, oh, I forgot what it's called. Dial. Why does that not come up? Little dial dot go. Connection flag. So what's a connection flag? This is an int 32. So it's probably just going to be like details of whether or not. Actually, let's dig into that a bit more. It's in server. So is it just a type then? And they've given it 4 different types, and just have a flag for if it's a dynamically dialed connection, statically dialed connection, inbound connection, trusted connection. Cool. That's great. So it's just a mapping of eNode IDs with connection flags. So we add them, we remove them. What else can we do? We just got an infinite loop. And it gets this free dial slots. And then takes how many static dials we've got. And then what? What's nodes in? We do a check dial. If we've got a node come into the nodes channel, we do a check dial. And if it fails, we discard that candidate. Else we start dialing. We create a new dial task. Interesting. Done channel. We delete. We task ID. We delete the dialing update static pool done since last. So I'm not sure if this is maintaining a list of people we can like connect to, or maintaining a list of like open connections with them. Add peer channel is what came up before. So if something comes into it, add static channel, remove static channel, history, context is done, then we quit. For range in dialing, so we get our slots. There's our nodes channel. There is our nodes channel. So we take this nodes in and put it into there. Then this opens up. So it's 100%, it's maintaining a list. And it just wants us to make sure that we've got open connections with these people. So where does this get called then? CD peer-to-peer loop. What's going to come out of this? Not very much, probably. Small names that you can't search. Server loop wait group. Yeah, okay, that doesn't give me anything. Maybe if we find something that's got peer-to-peer / dial in it. Nothing's got it. kind of leaves me a little bit of a unknown way to find where it gets called. Node dialer. Okay, let's find where this dial schedule is created. It's called new dial schedule, I think. New dial scheduler. And it is called in server. So what does it do? Set up dial scheduler. So when this server starts, it calls setup dial scheduler. And then that just calls this new one on it. And then what? We call add static nodes to it. And that's it. The server just opens it up. But it calls d.loop with the config. Config is that. We've got an enode iterator. Serve discover max. Discover misc. Discover mix. And an enode iterator. Wait, what was that? This is the fairness knob for the discovery mixer. When looking for peers, we'll wait this along for a single source of candidates before moving on and trying other sources. It's an enode fair mix. What was it called? It's not there. Where is it? Fair mix. Enode iterator. Fair mix. Fair mix aggregates multiple node iterators. The distribution of nodes returned by next. Okay, so this has a mix source, which I suspect is going to be our list of nodes. And when we're like choosing nodes, we just call this next on it, which is not a member, it's a function, I imagine. Return to node from a random source. Yeah, okay, so we maintain a pool of nodes, and when we need to use them, we broadcast them out, like send messages and have to broadcast out to them. And we'll just have to like call it. So it'll be like, you want to just call, give me the next one, and do that like 5 times. And that's all your logic in Yellow wants to do. So in our server, we've got a fair mix, and we pass it the iterator. And then it calls reads nodes with the iterator. Yeah, so it calls the next on it. So it just gets out a node and then passes it into our nodes in. And when does it come out? When is it done? It doesn't, it gets them all out. When this context says done in D. Cool, so that's what read nodes does. So this kind of doesn't actually go into how it sends a message out. This is just like between, we've got a big list of pools in like a structure. And this iterator is just manages them. And it manages them in a way that you can just call give me the next one. Next is a channel of a node. What's a mixed source then? Ah, that makes sense. There's an array of mixed sources. So what's next do? Returns a node from it. It calls pick source. If source equals nil, return m from any. Next from any. From any. Alright, pick source. Chooses the next source to read from. If it gets the sources, which is this in iterator, so is I guess a list of its iterators, and it picks a random one. It just gets last. It's an iterator. It's an integer, not an iterator. Pick source. Next. Slicer iterator. Okay, so we've got a fair iterator and we've got a slicer iterator down a bit below. So they're all, it defines this interface and it gives a different thing. You can cycle all nodes and you take in a node, returns an iterator. Ah, right, so those fair mixes over top of like one of these iterators. And they are this iterator interface. So we've got an array of these iterator interfaces. So fair mix has got an array of iterators, and those iterators can be different types. One is like cycle through everything, like one by one, I guess. Up here, it just has to have next node and close on it. So you call read nodes on it, and you pass it an iterator, and you call iterator nodes, and it creates a type, which will run through it given once, or this one runs through it indefinitely. This filter checks it. Cool. Not going in the right direction, I think, at the moment. So in our dial, yeah, we maintain a list. Add peer, move peer, loop around. So this just maintains it. I'm looking for like a broadcast. Reads the nodes. No. Login stats. Nope. History, login and stuff. Free dial slots. That came up before. think it just like you set your max number of peers and how many max you've dialed or connected to. And it'll open up your static ones, and whatever the difference between your max and that is how many peers it'll connect with. Start static dialer. Add to static pool. Update static pool. It's all pool management at the moment. A dial task is generated for each node that is dialed. We call run and we have a dial scheduler. So we create a dial task, which we have a destination and flags. And then when we open that up, we call it with our dial scheduler. So I think it'll take this task we've made, and then it will use this iterator this scheduler to go over all of the nodes we have and then send this message out to all of them. So t.dial with D being our scheduler and a destination. Maybe not. It's got our pool and we know who we want to send a message to. So we go grab the pool and we say, hey, look, we're going to dial this person. But you have to give me that destination using this pool, because this is all we have access to. Resolve attempts to find the current endpoint for the destination using discovery. D.dialer dialer for context. Then we have a new metered connection and setup function. Nah, and we're at the end of this file. So this is not actually where I wanted to be. Maybe this message thing. I think if we look in message and try to find send like a message, and then maybe it'll take us to somewhere not in the P2P code. Nah, because then I'm searching to send. Read message, sends back. Write message, maybe. They all kind of call it. It still might be too low level. All right, let's do something different. Where are we? So if we look for Go Ethereum / peer-to-peer, let's see what's got it in it. We ignore the miner and the peer-to-peer stuff because that's not interesting. But I'm looking for something like in a node or in a blockchain. Actually, the miner might be a good place. All the peer-to-peer ones have something in it. More peer-to-peer. We only had S. ETH. ETH handler protocols. ETH protocols, ETH backend. There's a peer set in this ETH. Nah, there's too much stuff here. Okay, here's something different. We go down. In miner, let's try link it so it's like you found a block. What do you do with it? I think that should be easy to find. So we go back, we go into miner, we just search found. Foundation. So we've got to handle ceiling, because we found this before. Now I've got to dig back in and try to find it again, which is always fun. No relative. Chain, right block with state. New mind block event. That might be what we need to look for, because it's going to a channel. Mind block subscription sounds like what we need to go. Core events. Handler. So mind block. So it's this mind block subscription. Okay, here we go. So we've got a broadcast loop here. Mind block subscription is part of this handler. Is that what it's called? Structure? Yeah, handler structure. Then when we start it, we subscribe to the mind block event channel. Stop in it unsubscribes. Yeah, cool. Mind broadcast loop. It'd be interesting to see what this gets called. But when it is called, we range over the items in this channel. Then we pull out this event, and then we pass that event block, so block that's in the event, cool, to this h.broadcast block. So mind broadcast without a capital P. So when we call start, it sets it off in its own go routine. So it just like when we start the handler, it's just listening for them. Here's another one, new transaction event. So this will be something like when we create a transaction, maybe, or someone sends a transaction to this node. Anyway, so our mind broadcast loop is always running. It's just sitting there and it's listening for when we do find a mind block. So we've got a miner running over here, it finds a block and it checks it to the channel, and then it keeps doing stuff, I imagine. Then this channel's sitting here spinning, just doing this loop. And when it gets a message, it goes, cool, I got this message. pulls it out as this event. And I could dig into how this block event is structured, but I don't think I care, because all they're doing is pulling block out of it and calling this broadcast block. So we've got broadcast block. Here we go. It will either propagate a block to a subset of its peers, or it will only announce its availability depending on what's requested. So it sends it to everyone, or it tells everyone it's got one. Is this all this handler function does? Broadcast transactions, broadcast blocks, broadcast mind broadcast loop, transaction broadcast loop. So handler looks like all it does is receives blocks, receives transactions, and sends them out, which is interesting, because this is probably like the missing connection between we have our node running and we have our blocks coming in and sending stuff. Run ETH peer. Registers an ETH peer. So this probably, I'm not going to dig into that right now, but maybe it adds a peer to our peer-to-peer layer. And this handler, it's just new handler. We've got the structure, we've got new handler. We got one weird new peer, add new peer thing in there, which might be interesting to dig into. And then we got our broadcast loop, and that's pretty close to where we need to go to see how it sends that block with mind out. So where is run ETH peer called? Run ETH peer. It is called in that function itself, I think. ETH handler and ETH handler ETH. ETH handler? ETH handler ETH. Great. Great naming. ETH handler ETH test. God. Yeah, it's small. Why are you existing? Implements a backend interface to handle the various network packets that are sent as replies or broadcasts. So it must have a chain, a state bloom, a TX pool. I haven't seen any of these. Unless these are like member functions. So, not member functions, members. It has a chain, which is, no, here it is. Yeah, it does. It has a chain, state bloom and TX pool. A state bloom and a TX pool is there. So our handler has a pointer to the blockchain. It has the transaction pool, or it has a copy of the transaction pool maybe, or it has its own transaction pool. A state tree. So all this is this is just an interface for this handler. And I guess when we go on to implements the ETH backend interface. So I'm assuming our blockchain structure has an ETH handler in it. equals accept transactions handle when it receives a new remote message. Handler headers. No, unsure what any of this, like the context of any of this is. Righto, no. Let's go back. And it's going away from the direction I want to head to. So, broadcast. Broadcast block will propagate. So we get the block hash. And we go into our handler, dig in our peers, and find peers without the block. If propagation is requested, send to a subset of peers. Get block. So it finds if it's got a parent. And if it doesn't, it gets sad. It logs an error. Says you can't send a block that's got no parent because it's just not part of the chain. Peer async send new block for peer in transfer. So peers is an array and we do a square root of the length. So that's just some like subset they've chosen. If we choose to propagate, then we get our list of peers. We find the peers without the block, get a subset of them to transfer to. Then we iterate through all of them and send async send new block. This is good. This is very good. First of all, what is peers on the handler one itself? Because we've got what we've got is a peer set structure. So this peer set structure is defined in Ethereum. In a downloader? No, it's got its own file. Peer set. How big is this ETH folder? Quite big. Which makes sense. I think it's just above node in terms of like you spin up the main structure, the main folder, main file even, main function, whatever. And then it's got a node. So the main spins up a node. That node spins up an Ethereum structure. And I think in the Ethereum structure, it also spins up like the blockchain, the peer-to-peer. The peer-to-peer through the handler probably. Anyway. Peer set. We've got a peer set. It's not a very big one, but mapping of ETH peers. What's an ETH peer? It's in Ethereum, it's a peer. It's this. What do we got? We've got a peer. Here. ETH peer is a structure. And it's just of type peer. So what's it called? We've got a peer set, which is a mapping of ETH peers. And an ETH peer is just wrapping around an ETH peer, which is just a pointer to it. ETH.peer. So what peer is that one then? Protocols, ETH. ETH peer. So we define in our protocols. Here is a peer-to-peer import. This is looking good. So in our peers, it is a wrapping around a peer-to-peer, P2P peer. And we've got some relevant information about that peer. Like, we know what blocks that he knows. Known transactions, known by that one. Transaction pool, unsure what that means. Used by the broadcasters for liveliness. Hopefully it's very lively. So we've got a peer-to-peer peer. So we've got P2P peer back in here. So our handler has our peer set. That peer set is wrapping around peer, which is wrapping around peer, which is wrapping around peer. ETH peer, ETH protocol peer, peer-to-peer peer. Say that as fast as I can. So that's great. We've got this peer. We've got a link. What do we call on it? We call we find peers without block. So we go into our peer set. We go find peers without block. So we have a list, an empty list of ETH peers. So this ETH peers, and we got our peer set. We iterate through all of these peers, and we call known block. So call known block. What? It's not in there. No block is not defined in this ETH peer. It's defined in this one, protocols. Peer set dot peers goes into this one. So maybe it doesn't use this one. Anyway, it calls known block. And then we go contains hash. So we've got just an array of hashes. And we've got on this peer structure a bunch of like useful information about those peers. So we go find in this array that's kept alongside of our list, alongside of our peer, he's got a hash. And so we find that. And then once we find whether we do, we take not. So if they don't know it, it's good, we're going to send it to them. So we've got our list. So we do our stuff, get in chain. We call async send new block. Async. It's not in there. Why not in it? It's on the peer set? No, it's on the peers. Async. It's not in there either. I think this one's actually not in there. Here we go. Sync. Send. This looks like we're going to get it. New block. Send new block. Not a block hash. If propagate, we can send the whole block itself. Otherwise, we send a new block hash. We send the block if they want it. This propagate is defined somewhere. Probably whatever type node you are. Some config. Uninteresting. We are so close to getting it. Async send new block, not the hash. We want to see what happens when we send the block. We create this block propagation structure with just a block. We add it to queued blocks on this peer. Then we add that interesting. We add that to the block hash. Mark all the block hash as known, but ensure we don't overflow our limits. Whatever. Queued blocks on this peer. Blocks. Is in a channel for block propagation. Where does it go after this? It's not in this file, which is not great. ACK QUE UED blocks. ETH protocols broadcast. All right, so somehow in this interim layer we were talking about, ETH broadcast, which is getting very close. It sounds like this is the last level before they call it. So queued blocks, queued block announcement. We call send new block on that peer. Which is it. So it comes straight back. But I guess that's what async does, right? We call peer-to-peer send. This is very good. Very, very good. We make a new block packet, which has the block and the TD. It's a new block message. I don't know where that comes from. No, it's going to be a static thing. It's just going to be like a string. New block. Now, what was it called? It's not there. It's going to be just 007. Oh, here we go. There is a link. 007. So we call peer-to-peer send. And I don't know what p.rw is. Message read writer. Output streams for snap. I don't know, is that coming to our like standard out or is it? Unsure, whatever. Wait. Peer-to-peer message read writer. Maybe that's where we send it to. We actually just write to there. So we go back into peer-to-peer. We go for send because we want to send it. Where is send defined? Probably on that peer. No, it's not. It's a capital B. writes an RLP encoded message with given code. So we've got a message writer, we got our message code 007, and we put in this data interface, which is our new block packet. Close, so close. We don't need a worker anymore. Don't think we want to handle. I don't think we need a broadcast. We do want to get message. And I think we should leave that open. Send. RLP encode to reader, taking the data, and go onto W write message, code message, size, payload. Awesome. So all it's doing at this point is just putting it into this RLP format, wrapping it in this message, and then sending it to this W. So back on our block, did it create the block in here? Was it created in this other one? New block packet, where's that? ETH protocols to structure. So we got new block packet, and it's just nothing. It's absolutely nothing. It's a structure with the type block and a big int. I don't know what TD is. What's in this file? Because this seems to be kind of coming up. It's just got. There's all our messages. Interesting. Status, new block passage, transactions. Anyway, I think this is now digging into implementations. That's got the connection we need now. But I might leave that until the next video because I've made a pretty good connection there, and I think that's a good stopping point, and we're just going to be opening up a new can of worms now. So, thanks all for watching. Have a good one.